right, hello everybody. Welcome to Debunking Other People's Data Science. My name is Marianne Bellotti. I am a software engineer. I specialize in data infrastructure. I currently work for a little organization you might have heard of called the United Nations. I'm also the CTO of a little startup that works on gaps in current data infrastructure and software called Xversion. Primarily what we're working on is version control for data. I'm also a vicious, horrible liar all the time. And I'm not alone in that. What I find particularly amusing about this tweet is that most of the people who retweeted it are other data people, data scientists, other programmers who work with data like me. But really, there's a guy called Pete Worden who kind of put it more succinctly. He said, I get all the credibility of genuine science without having to do any of the work of genuine science. No peer review, no reproducibility. And everything that I do, even if I do it for fun, is just sort of kind of like appreciated as a scientific study. He's not like some louse. He's a serious guy. These are some books he's written on data and data science for O'Reilly. So, he knows what he's talking about when it comes to data. And this is the visualization that he was talking about. Now, this was done in 2010, and by 2014 standards, it must look ridiculous. How could anyone possibly take this seriously as a scientific thing? But people did. He scraped all of his data from Facebook and started drawing connections between people who they knew and who they knew, and then tried to sort of generalize that and seeing which parts of the country were sort of more in communication with one another. And if you have time later on to look up his blog post where he's explaining his process and why he was kind of shocked that people thought this was scientific, it's really worth reading. But just sort of a general summary, the lines and the connections are pretty defensible from a scientific point of view. But he then put it in MS Paint and decided to just kind of eyeball little regions and color them in different colors. And then obviously the news are pretty facetious. I mean, we think that he thought that would be clear, and yet it was picked up by all of these respected publications as this is proof that America is becoming more and more polarized. Look at this amazing scientific study. And so herein lies the inherent problem with data science. It's about taking simple components, simple relationships of complex things, isolating them and studying them. And whenever you do that, by the very nature of doing that, you're going to be missing the entire story. So the real problem we have with any kind of data work is that we trust it as science, but we don't enforce scientific methods on it. People see a number and they think, oh, this is a fact. There are numbers in Sesame Street, too. So just having numbers does not necessarily make something scientific. So let's start with some examples. 35% of data scientists think data science is a buzzword. Before we start talking about this stat, how many data scientists do we have in the room right now? So a couple. How many people are really more hackers, programmers, but you like to play with data, you like analyzing, screwing around? Okay. How many of you think that data science is a buzzword? Way more than 35%. Awesome. All right, so this stat is a horrible, vicious lie. The first reason why it's a horrible, vicious lie is because I made it up. But even if I hadn't have made it up, it's still a horrible, vicious lie. Because I'm holding this number 35% up to you and saying, this is significant, but I'm not giving you the context. I'm not telling you why that number is significant. Is the number significant because it's the largest number in my study and all of the other results were various fragmentations? Or is it the fact that 65% of people don't think it's a buzzword, and I'm just hiding that fact from you so that you think the 35% is really important? You have no way of knowing why this number is significant because I'm not giving you the information that you need. And reporting only part of the analysis is a big way that people lie with data science and statistics in general. It's kind of sometimes called the Malcolm Gladwell school of data science, kind of picking a stat from this study and a stat from this study and a stat from this study and going, conclusion. So it's very common. A big theme of this presentation is going to be idea missing information. And I would always say that the most important thing about a data set is not what was collected, but what wasn't collected. What information isn't there, and how were those decisions made? So the first question I want to go through with you guys is, how are things defined? So let's say, hypothetically, we wanted to do a study that produced a statistic like this for real. How would we go about doing it? Well, you're probably thinking, oh, it's easy. We just get a whole bunch of data scientists and we ask them whether they think it's a buzzword and we count how many they are and then we have a stat, right? And okay, sure, you'd be right. But then the first question we have to answer is, who are the data scientists? So we can say, as a sort of a thought experiment, let's say we have a population, and we kind of like roughly break this population down into 3 general categories of people who might be data scientists. And in the first category, we have statisticians. But we also have analysts, people who work for Goldman Sachs, who probably got their job because they went to an Ivy League school without any like actual formal training in statistics per se, but they work with data all the time, and they produce analysis, and they build models, and they're all smart people, so they probably do an excellent job. And then we also have people like us, hackers, who kind of play around with data. But we also have hackers that build data tools, they build analytics. But then you have people like me who kind of do more data infrastructure. So are those people considered data scientists? And then you have, of course, academics and so-called data journalists. Are those people data scientists? And before you collect your data, you have to actually make a completely subjective decision about who among these groups of people are considered data scientists and who aren't. And then once you do that, you can do your study, and then collect your data, and then produce your results. But that's an incredibly subjective process, and it's a necessary evil. It has to be subjective. So you're probably thinking, okay, fine, but realistically speaking, we're all going to agree, like roughly, who is the data scientist and who is clearly not. And if there's a little bit of leeway, what's the big deal? So I'll give you another example. Silicon Valley versus Silicon Alley. So this is a data set that I've been working on for, I don't know, about a month or so. I scraped it from Crunchbase. And I'm kind of looking at relationships between the funding activity of Silicon Valley versus Silicon Alley. Sort of what the data looks like. It's a whole lot of information. And if I wanted to just very simply have a place to start, I could say, okay, what are the number of startups in each area? The Silicon Alley, Silicon Valley. So this is some pandas code. There have been a lot of talks that have touched on pandas, so I'll just start by saying that it's a statistical library for Python. Very briefly, the first line just loads the CSV file up into a data frame. A data frame is sort of like a table in pandas. It has columns and rows and all of that. And then the second line creates a new data frame based on the first data frame by saying, look, okay, take the column headquarters and group everything by what's in their headquarters value. So put all of the companies that have their headquarters in New York, put them all together, count how many there are, and then put that data in a new column that we're going to call count, and then reset the index of our new data frame so that all we have are the headquarters and the count. And then the last line just says print out the first 100 rows. So that's what we get. We get all the headquarters and how many startups have that as their headquarters. And as we're playing around with this data, we find that immediately we have a problem, because Crunchbase allows people to select their headquarters via free text input. And free text is the enemy of data, because some people, most people in New York put down that it was New York, New York. Some people put down New York City, New York, which is stupid. Some people put down New York City, some people put down New York, and if you would go further in, you would see some people put down Brooklyn, New York. Okay, fair enough, but come on, really? And then some people put down Queens. So in data, what we refer to this as a normalization issue. And there are 2 ways that people primarily, when they talk about normalization, they're either talking about one of 2 things. They're either talking about what this is, which is normalizing variables, making sure that all your categories are consistent, and then normalizing the data set itself, which is making sure that it has or assuming that it has sort of a bell curve formation, which we'll touch on a little bit later. So, all right, fine. It's a little bit annoying, but it's part of the data cleaning experience. You just figure out all the various ways people have of saying that their headquarters are in New York, and you put it into a script, and you say, change all of these so they're all the same thing so that Panda knows how to deal with them. Awesome, that's easy. Now we get to the second problem. Where is Silicon Valley? Anybody, where is Silicon Valley?
Somewhere between San Jose and San Francisco.
Could you be a little bit more specific of that? Okay, somewhere between San Jose and San Francisco. I was waiting for someone to say California, actually, which would be the most correct answer. So I decided to go to the source of all knowledge, which is naturally Google, and ask this question, where is Silicon Valley? And this is the answer it gives me back. It's mostly San Jose, in the area around San Jose, and Palo Alto, and Mountain View. And I'm like, awesome. There's just one problem with this definition of Silicon Valley. What is it? What? What about San Francisco? So here we have a huge problem, because technically, San Francisco is not part of Silicon Valley. If you're going by the geography and the meaning of the term Silicon Valley, San Francisco is not a part of it. However, there's been sort of a gradual shift over the last 10, 15 years where a lot of startups no longer want to have their headquarters in Mountain View or Palo Alto. They want to have it in San Francisco. So colloquially, when you say Silicon Valley, first thing people think is San Francisco, or at least the San Francisco area. So here are 3 stats that I pulled off of Wikipedia's page on Silicon Valley. A third of Silicon Valley scientists and engineers are immigrants. Females outnumber males. And Silicon Valley has the most millionaires and most billionaires in the United States per capita. And these are 3 statistics that hit on 3 very polarizing, very controversial issues: immigration reform, diversity, and the gap between rich and poor. And these are 3 stats that people might throw out to change your mind about what's going on with this. And we have absolutely no idea whether that includes San Francisco or not, which is a huge problem. So the biggest way that people lie and mislead with data is by using misleading definitions, using a term knowing that you're going to think that it means X, Y, Z, when the actual data they collected was collected thinking that it was ABC. I'll give you an example of this. This is an article that appeared on ValueAg, I think about 2 weeks ago. It's actually probably still on the front page of ValueAg because they never update that blog anymore. But it is a little blurb about 2 reports published by the Brookings Institute. And they give this wonderful title, "American Entrepreneur Spirit is Dying," which is a little dramatic, but the actual report sort of took it slightly toned down, but same sort of idea. And they're saying that these reports kind of like show a decline in entrepreneurship in America. And it's sort of like, oh, okay. Little piece of advice: whenever somebody posts an article like this, always follow the links. You'll be surprised how often people don't actually follow the links to the actual study. And 9 times out of 10, when I read the actual study, it doesn't actually say what they think it says. And in this case, on the first page of these reports, which are very well done reports, they had a little footnote telling you where the data came from. They used this government data set called the BDS. And if you actually read the code book for the BDS, and any government data set that's released on a fairly regular basis will have a code book sort of explaining these are what all these terms mean, and this is how things are defined. If you read the code book for the BDS, it becomes very clear that it's obviously collected to do job creation stats, because they have all things like how many jobs were created this quarter versus how many jobs were lost this quarter by this firm. And so because of that, when they were counting companies, they don't count sole proprietorships. They don't count situations like most startups start out with, where it's you and your co-founders. They don't count freelancing. So is it true that entrepreneurship is dying, that no one is forming companies anymore? Or is it the case that people are shifting the way they're doing things, so there's really more sole proprietary freelance situations? We don't know. Here's another example I find even more amusing. It's from oh God, I lost my speaker notes. What's Nate Silver's blog name? It's 550. I always switch the 5 and the 3, and I don't know why. So 558. 38. Okay, I'm going to do that probably a couple times because I can't see my speaker notes on here. But anyway, it's from Nate Silver's blog, and it's about eHarmony and what characteristics people look for when they're matching with people when they message. And the important part of this is they're talking about men, and they say that they still prefer mates who were similar in terms of height or attractiveness. Those are the most important characteristics. And then there's a footnote in which they say attractiveness was one of the traits that eHarmony put together in this data set, but when we asked how they calculated it, they didn't respond to us. So one of the most important characteristics is magic. We have absolutely no idea what this number means, or we can't really, dig into it at all because we have no idea how it was calculated. Another way that people lie and mislead with data science is by failing 5th grade math. This is my favorite infographic ever in the history of infographics. It was published on Mashable, about 2010. It is comparing people who play Farmville to farmers. Okay, let's ignore the fact that there's absolutely no earthly reason to make that comparison at all. Let's just assume that Zynga sponsored this and then just go from there. And it starts off all right. It's just basically, descriptive statistics of the average. Most Farmville players are female, most farmers are male, these are the average ages, their average salaries. All right, cool, fair enough. Then you scroll down and you get to this lovely, lovely piece, where, for those of you who can't read this, it is saying that Zynga made 200% more net profit than Facebook itself, and the comparison number is The agriculture makes 5% of the gross world product. The only thing these two numbers have in common is that they both incidentally happen to be percentages, but you're obviously meant to sort of go, oh, 200 is so much bigger than 5%. That's amazing. For those of you who still don't get why this is a problem, let me put it this way. You can have 75% of a hot dog, or you can have 40% of a pizza. Which one is more food? You cannot compare percentages of things that are not the same thing. You'd be surprised how often this happens. And I would say that in general, when you're looking for math mistakes at data science, it's usually the 5th grade math level stuff, because the more complicated stuff we use computers to do, and so the computer gets it right, it's just a matter of having the inputs right. So that brings me to what I'm sure you all want to know. How do you keep nasty people from yelling at you over Twitter when you do your little data experiments? The first thing to do is clearly define your assumptions. Everybody who works with data knows that you have to make assumptions. Everybody who works with data knows that it's subjective and that there are certain flaws that are just naturally part of the process. So admit it. Say, like, this is the assumption I made. This is how I characterized this. This is what I was defining. How many of you saw Eric's wonderful talk yesterday about human trafficking? Awesome. I'm about to blow shit up. In 2003, the UK government estimated that there were 4,000 trafficked women in the country. And this stat was then reused by the Salvation Army and by the State Department. And everybody was like, wow, 4,000. However, the actual number of trafficked women the police could find was about 71. So 71 out of 4,000. Either the police are really awful at their job, or there's something wrong here. And when you dig into that stat, they generated it by estimating that all women in the country who had not been born in the UK, who were working in the sex industry, were trafficked, which is sort of an amazing assumption to make. Apparently, if you're born in the UK and you want to become a prostitute, cool, but if you're born outside of the UK, then it must be because you were trafficked. So, and everybody kind of ended up looking stupid because it overestimated the number of sex-trafficked sex workers in the UK. Here's another example. This one was published in Forbes. As the title would suggest, it is claiming that not Chinese, not English, but French will become the most important language in the world in 2050. And I'm sure the French really like that thought. But the way they calculated this is by estimating the population growth of the countries that had French speakers in it. So they did this by taking all the countries where French was an official language, and I have underlined N for a very specific reason, and then calculating out how many people there will be who speak French in the future. The problem with this may seem fine until you consider that French is an official language of Canada. So the entire population of Canada was included in this analysis, and I have many Canadian friends that I speak more French than they do. So
How much sarcastic clap did that get?
How much sarcastic? I mean, this is the really funny thing about this presentation is that finding these examples was not hard at all, and a lot of these examples are only like a week old, so it's really common for these sort of things to happen. Okay, so this is how I get away with lying as often as I do, is that when I write blog posts about different analysis that I've done, a lot of what I'm writing about is not the actual analysis, it's the whole process of like collecting the data and my thought process of doing this analysis versus that analysis. And people find that really legitimately interesting, so they tend to ignore the fact, like the assumptions that I've made that they object to. It's also a really nice discussion to have because data doesn't actually tell stories, people tell stories. So the process is kind of more interesting than the analysis. Aim for replication. And by this I mean disclose your data. This is like the big difference between the scientific process and what we call data science, is that people hide their data and they don't talk about how they constructed the experiment in the first place. They just give you a bunch of graphs and they go, look, science. This is slightly self-serving because one of the things Xversion does is try to create kind of a GitHub-like experience for uploading your data. But regardless of what system you use, if you've collected data, disclose what the data is so that I can download your data and kind of poke around with it. I may confirm your results, or we may find something more interesting in the process. then test for basic skews, sampling errors, and other factors, because your data may be inherently bad. And so this is a fun example also for Nate Silver's blog. I would say when they're right, they're right. When they're wrong, they're really wrong. So what this is these are two visualizations that were included on a post about the rates of kidnapping in Nigeria. And the one on this is my right hand, so the right one in white, it was actually an animation. And it started, I think, at around 1960, and then every time there was an incident of kidnapping, you got a little red bubble that would just like explode, and as it played, more and more bubbles happened. And then the one on the other side is actually a heat map of kidnappings per 100,000 people. So does anybody think there's anything slightly odd about the heat map? Yeah, what's odd about this heat map? Well, that's a screenshot of wherever it was in that particular animation. Yeah, it was like dot 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 dot, and I was like, I just need one image to I'm not putting an animation on my keynote. But yeah, that one area, you got this one red spot right in the middle of the map, and it's surrounded by like a dead zone. And generally with a heat map, you sort of expect it to be a gradual shift in color. So there were two things that tripped them up because they didn't actually look into researching where the data came from. The first is they used a data set that is not actually a data set on frequency of kidnappings. It's a data set about incidences of media reports on various things. So are they really tracking out an increase in kidnappings, or are they tracking out an increase in media coverage in general? Are they tracking out this sort of like insane media like craze about kidnapping specifically? The second problem that they have with this data set is how they chose to handle null values. So when they had a case where they had a data point and they did not know where the kidnapping actually happened, they would default to the capital. So the reason why the capital is in bright red is because that's how they handled null values. They said, okay, this is where it happens. Despite how smart all these people are and how good they are at statistics, nobody picked up on this until they posted it, and then they got their ass handed to them on Twitter. So it's really important to test. And this is kind of like interesting because yesterday I had this whole idea in my head about what I wanted to present, and then when I saw everybody else's presentations and we're all talking about Python and I love Python, I got really, really excited, really inspired. And somewhere in between trying to troll Rob Spector's demo by feeding it Go-Go Bordello lyrics, I had an idea, and I was like, we have libraries for unit testing, and we have libraries for integration testing, and we have libraries that test validation of different formats, but we don't really have libraries that look at really basic things like what's the likelihood that this data set is skewed? What's the likelihood that this is normally distributed? What's the likelihood that you have a problem with your variables not being normalized? We don't really have anything like that. So I decided to start it at 8 o'clock last night over beer and pizza. I'm not serious. This is like, I don't know, 12 hours old. So let me start off by saying, how many of you have always wanted to contribute to an open source project but never do? Raise your hands up. I know there are more of you. There is literally like 2 Pi files in this repository. You should definitely come along and kind of help me figure out how we're going to test various data sets to give people an idea of whether or not the data that they're going to be using is good at all. And I thought I would use my remaining time to kind of do a little demo since this is, in fact, PyCon. Oh, I may have to mirror my display. Hold on a second. All right. Cool. So remember that data set I had in the very beginning of my presentation where I said that we had all these different New Yorks, and we wanted to sort of figure that out. First thing I wanted to do was sort of build something that could analyze that. So this is how it runs. It takes a CSV file, and it does an assessment of your column values. And so let me scroll up. The first thing that I thought was really interesting when I ran this is that it managed to pinpoint the idea. Oh, wait, where'd it go? Oh. It got an alternative spelling of Kiev that I didn't expect it to. And hold up. Yeah. Where are we in New York? There we go. And it finds all the different ways you can say New York City, and sort of gives you an idea of, like, here are all the values in this column. Here are things that may be reproducible, maybe duplicates of each other that you may want to normalize. So, oops, let me go back here. I can show you the actual code. Because I was like, oh my God, I'm going to have less Python code in my presentation than Randall. That can't happen. Oh God, internet has failed me. Everything will be okay, just reconnect. Hold on. There we go. All right. I put it in the X version group because there is nothing of use in my personal GitHub, and so why should we change that now? So here we go. I'm going to go into the Normalized Pi file, and I'm going to explain very briefly what is going on here. It looks for columns that it can identify as basically strings, so they're not ints, they're not floats. And then it tests to see if the sum of the values in the columns when you count them up is less than 2. And the reason for doing this is that if your average for each category is 1, 1.3, something like that, then it's probably just a free text field where it's not a category. So that just saves some time. And then there was this nifty little module in Python that I had never heard of. And it's always fun when you find great things in the default library collective, called difflib. And it has this thing called get closest matches, where it can feed it an item and then give it a list. And it'll pick out the things in the list that are the closest to what that item is.